Okay, so for this assignment, you're going to be looking at molecule polarity. So you're going to click on here to go to the pHet simulation, and it's going to open up to this page. You're going to go to 2 atoms to start. Now these might not all be clicked on, but the first one is a bond dipole. And let me change these so you can actually see what happens with them. So the bond dipole is going to point at the more negative one, and notice how the end of the arrow looks like a plus sign. That's suggesting that the atom on this side is more positive and this one is more negative. So that's what the bond dipole is telling you. The partial charges are these symbols here. So this is telling you it's a charge, and this is telling you it's slightly positive. This one's a charge, tells you it's negative. So that helps reinforce the idea that this side's more positive, this side's more negative. And then we have the bond character. So right now the bond character is in the middle, but if I move this one, notice that my bond character moves to either more ionic or more covalent based upon the electronegativity. So you'll be playing around with that. The other thing we can do, the surface part, we're going to leave at none. You can click on this. It's going to give you electrostatic potential, so whether it's more positive or more negative. Kind of gives it a little cloud around it. And then the electron density, it just kind of gives you an idea of where the electrons are. But we're not going to be looking at any of those. So you can leave that at none. The electric field you can turn on. And then how that's going to work is, since this one's more negative, it's going to be attracted to the positive. And if I try to spin this molecule, it's going to spin back so that the negative's towards the positive and the positive's towards the negative, because that's how they attract. Okay, so I'm going to reset everything. Turn back on my partial charge and my bond character. For the first part, you're going to keep your electronegativity of A at low. And then you're going to increase and decrease the electronegativity of B. And you're going to document what happens with the arrow, the partial charges, and the bond character right here. Okay? Then you're going to switch it around and take a look at how that affects it. So it's going to tell you exactly what to do. You're going to put the electronegativity for A at the middle. And then you're going to go ahead and change the electronegativity of B and see what happens. So I'm going to let you play around with that and see what happens. For the 3-atom investigation, you're going to have to click to the other version down here. So this is how it's going to start. You're going to want your bond dipoles. That's going to be those same ones. So this shows from one molecule or from one atom to another. On the other one, we only had 2 atoms, so there was only one molecule dipole. But in this one, because there's 3 atoms, we have a molecular dipole, which tells us the overall change in charge and gives us an idea of if there's an overall polarity of the molecule. So the plus is going to be on the lower side of the molecule, and the negative is here, which if we turn on our partial charges, agrees. So this side's more negative than this side. But they make it such that the molecule dipole is just off to the side. It's not going to be drawn through the molecules. We can turn our electric field on and off. You'll see how it moves. And then you can change these around, which is going to have you do in a couple different ways for the activities you're going to be doing. Now this doesn't show up right if I bring it up, but you're going to work through these. Now keep in mind you can move the molecules. Whoops. So some of these you have to have it straight, and then it's going to tell you what to set the electronegativity at. Make sure that you answer what happens when you click the magnetic field on. Most of these are like draw it on the image, but then make sure that you describe what happens when the electric field's on for the last part of each of these. But otherwise, most of it's just going to be drawing on the image. So when we get down here, we'll have some summary questions. And then we get to the real examples. So when you get to the real examples, you need to click on this real molecules at the bottom. The real molecules will not have the magnetic field. You're going to predict where it's going to be for that. And you're going to have to click on this link because the new version doesn't, or the old version doesn't work with the website. So you're going to click here. It's going to go ahead and do the run chirp J browser compatible version. We're not going to download. And when you click on that, it might take a little bit to come up, but it's going to come up looking like this. You'll click on the real molecules up top. This is just the older version of the activity. You'll be able to change your molecule here. Everything over here is pretty well the same, but it does not give you the magnetic field. So when you have to predict what's going to happen with the magnetic field, you'll have to decide that based upon the polarity of the molecule. And you'll finish each of these, and then that's it. If you have questions, let me know.